And take a couple of seconds, reread the essential question in the I can statement to yourself, please. All right, Raina, can you read us the essential question? Perfect. And Alberto, can you read us the I can statement?
I can solve a rational equation and identify extraneous.
Perfect. Extraneous. Perfect. Okay. So we're going to talk about not just expressions. So when we did multiply and divide before the semester ended, when we've been doing add and subtract, remember there was no equal sign, right? We weren't solving anything. We were just simplifying stuff. All right. We're now going to move into the world of let's solve this. Okay. We're going to actually come up with a value for X. So that's what we're going to do, solve. Remember, the word rational just means fraction. And we're going to talk about this word extraneous solutions today as we go through this first little bit here. Okay. And we're going to be looking for that every time we do one of these equations. Okay. All right. I'm going to give you like 2-3 minutes. Remember, this is how Mrs. Ballard helps you do better on your II assessment, right? I make you read stuff that's hard and technical, okay? So take 2 or 3 minutes and read through that paragraph. See if you can find the vocabulary and underline the vocabulary, okay? Give you about 30 more seconds to read it to yourself. Okay, we're going to read just a little bit of it together, okay? We're not going to read the whole paragraph together, but a little portion of it. It actually gives us the instructions on what we are actually supposed to do. So Callie, can you just read us the first sentence? Perfect. I would underline that. Those are exactly what we're going to do today. Okay. We're going to multiply by the LCD, everything, and solve the resulting polynomial equation. Okay. Which is going to take us back to our quadratic solving and all of that stuff we did before. Okay. So we're kind of rolling, we're moving on to the next step here. Okay. It goes on to talk about the excluded value, which is some vocabulary I didn't teach you the last couple of lessons. Okay, so we're going to talk about it really quick right now. Okay. There is one number out there that we are never allowed to divide by. What are we never allowed to divide by? Yeah, we can't divide by 0. So if I get an answer that would make a denominator 0, I can't have that as an answer. Okay. That's what an excluded value is. Okay. So we're going to put it out here in the left-hand column. So a number or solution, okay, that makes the denominator equal to 0. That's Mrs. Ballard's definition, made up definition. Okay. So if I get an answer and I plug it back into the denominator and it makes the denominator 0, I have to eliminate that answer. Okay. So in expressions, in the multiply, in the divide, in the add, in the subtract, in the expressions, we call that an excluded value. Okay, we wouldn't have gotten any solutions to any of those, right? So I skipped over that part. When we talk about this in the context of equations, we now call that an extraneous solution. So an excluded value is the extraneous solution. We see extraneous solutions when we have denominators, okay, and when we have radicals. We haven't got to the radicals part yet. Okay, well, that's kind of one of the next things that's going to come up. Okay. All right. So our instructions say that we're supposed to solve each rational equation algebraically. All right. So we're going to figure out our LCD. We're going to start it like we did yesterday, and then we're going to multiply everything by the entire LCD. When you are writing these out, you want to leave yourself even more gaps of space. Okay. Today, you're going to write tiny. Okay. All right. Let me get to, I want to go to my drawer. Let's erase that little mark right there. Okay, so first thing I want to do is find the LCD. Okay, so I'm going to do this just like I did the other day. Totally forgot to put out your colored pencils, so I'm going to do that really quick. So right now, try to factor that second denominator for me while I'm passing out the colored pencils. Okay. What kind of factoring is this second denominator? GCF, what'd you get? 2 times what? Good. All right. I am just going to put my LCD off to the side just so I have somewhere to write it down. Okay. So, because I'm not doing equivalent fractions anymore. Okay. So hopefully this doesn't mess you up with what we do. So yesterday you have to kind of put on which process you have to do. When we don't have an equal sign, we multiply by what's missing in the LCD. When we have an equal sign, it's a little bit different. Okay. I'm going to still do the circle in blue what matches. So what matches? X minus 5. Okay. All right. So I'm going to write that down. How many times do we write it down? Once. So X minus 5 gets written once. All right. And then underline in red everything that's left, I just get 2. All right. It told us in the instructions, but sometimes it's worth writing it out a second time. Okay. So I'm going to use a different color. When we have an equal sign, that says have, an equal sign, multiply everything by the LCD. You have an equal sign, you multiply everything by the LCD. Okay. So I'm going to use the factored form of my LCD. I'm going to use that 2 times x minus 5. So I'm going to multiply this by 2 times x minus 5. And I'm going to multiply this by 2 times x minus 5. Okay. Do you see how this minus 5 and that x minus 5 would cancel each other out because one's in the numerator and one's in the denominator? My goal is when I'm solving to get rid of the fractions. Okay. I don't like working with fractions when I'm trying to solve something, right? None of us like working with fractions that well. I only have a 2 left, so what does instinct tell you you're going to do with that 2? Distribute. Even though it's at the back, we're going to distribute. Okay, so what's 2 times 3x? 6x. All right, what's 2 times 7? 14. Perfect. Okay. Look at across the equal sign now. We have 2 times x minus 5 in the numerator and 2 times x minus 5 in the denominator. What are we going to do? We get to cancel them both out. Doesn't that feel good? Right? Just like we were doing the canceling before Christmas. Okay? I don't have to multiply by anything. I just get to write down 5x plus 17. And then I celebrate a little bit because woohoo, the fractions are gone, right? I don't have to solve with fractions anymore. We got them to go away because we multiplied everything by that LCD. Okay? We're going to get the same solution as if they were there. Okay? That looks like a before algebra 1 type problem, right? Because there's no squareds. It's all linear, right? Okay, maybe it's in algebra 1. We've got to do at least 2 steps, right? But we can do 2 steps at one time because we're in algebra 2. That's what the 2 at the end means. All right, how do I move this 5 to the left? Add, subtract, multiply, divide. What do we got to do? Subtract, right? Because right now it's under addition, subtraction, right? So if I'm going to subtract 6x minus 5x, what do I get? Just x. Good. I'm not going to write down my little minus 5x underneath. Okay, if you still need that, write it down. Okay, but this is second semester. We're moving on to calculus next year. I'm not going to write it down anymore. Okay, unless it's a really super complicated one. Okay, all right. Algebra 2 means we do 2 things at once. At the same time, I'm going to move that 14 to the other side. How do I move the 14? Subtract again. So 17 minus 14 is what? We did that whole thing in 2 lines. Now, here's where I need to check for that extraneous solution. I know I crossed stuff out, but you kind of have to pretend you didn't, okay? If I was going to take this 3 and substitute it in here for that x, would I get a 0? Would not, right? Same thing with this x right here. I would not make it 0. So I know that that is a good solution. I know I can use that. That's what I would type into Otis for my test answer, okay? So just 3, okay? That's it on that one. Let's keep going, okay? All right, looking at B, I have no factoring to do, right? Looks a little different because I've got, whatchamacallit, I've got 3 terms instead of 2, okay, but that's not a big deal. I do have some things that match. So what matches? X minus 7. I'm going to circle that in blue. Even though it's only in 2 of them, we're going to still count that as a match. How many times do I write down what matches? Once. So x minus 7. I'm going to underline everything in red that doesn't match, and I get to write that down. So I have 2 times x minus 7. All right, so I know my LCD is 2 times x minus 7. I'm going to, even though it's 3 terms versus 2, I'm going to write down, I'm going to multiply all 3 terms by that 2 times x minus 7. So I've got 2 times x minus 7, 2 times x minus 7, and 2 times x minus 7. I'll let you catch up writing that down. Okay. Let's take a look. Looking at this first term, what are we going to get to cancel? X minus 7, which means what am I doing with this 2? Distribute the 2. So what's 2x times 2? 4x. What's 2 times negative 9? Good. All right. I'm going to go to this third term here. What gets to cancel? 2's are gone. What am I going to do with this x? And double check. Make sure if there's a minus sign, the negative would get distributed with it, just like we did yesterday. Okay? So what's x times x? X times negative 7. Good. All right, I'm going to write the equal sign. So I'm still following the operations that are there. I have to write the equal sign. Across the equal sign in this third term, what cancels? And then I multiply just 5 times 2. It's 5 times 2. Woohoo! The fractions are gone, right? We celebrate a little bit. We don't want to work with fractions if we can help it. Okay? What you need to notice now is that we get a quadratic out of that? Okay? So I'm going to combine like terms. At the same time I'm combining like terms in order to solve any kind of quadratic, whether we factor, quadratic formula, complete the square, what does it have to be equal to? Who remembers? Has to be equal to what? 0. So at the same time I'm combining like terms, I'm going to move that 10 to the left in the combining like terms and get it equal to 0. So I'm doing it all in one line versus multiple lines. Okay. All right. So I'm going to put that x squared up front. And typically, like we get x squared, the x, the constant. Okay. All right. Who is friends with 4x? Negative 7x. So what's 4x minus 7x? Good. All right. And then I know I've got this negative 18 and I have to move the 10 over. How do I move the 10 over? Subtract. So negative 18 and negative 10 is what? Good. Equals 0. Okay. Your head should kick in right now and really want to be doing something. What do you really want to do right now? Magic X. Good. Okay, so we're magic Xing this part right here. We know we've got to factor that. Okay. This is a little different than the last one, right? Is because we ended up with a quadratic instead of a linear. All right, so two numbers that multiply to negative 28 and add to 3. What do you think? Everybody go? Negative 7 and 4? Okay. I'm going to write it out as a binomial times a binomial. So we've got x minus 7 times x plus 4 equals 0. Okay, we haven't done this part in a while. Okay. What property do I need to apply now? Had a special name. Good. Okay, so I'm going to apply what we call the zero product property. Okay, that says property. It does not say it very well, though. Let me try that again. Zero product property. What that means is I'm going to take those two binomials and separately set each one of them equal to 0. Okay, so the process is setting them both equal to 0. Okay. What do I need to do with this 7 to move it over to the other side? Add it. Good. So we just get x equals 7. What do I have to do to move the 4? Good. All right. We still need to check to see if any of those are extraneous solutions, meaning can I put this into my denominator and not get 0? So I'm going to check that. Okay. Looking at the 7. If I put 7 into here, what do I get in my denominator? Because can I have 7 as an answer? No. All you're going to do is just cross it out. Okay. Don't go through and erase all the work. All that work is still important. Okay. Your signal to me that you understand it's extraneous is cross it out. Okay. And you're not going to type it in your Otis answers. Okay. But in your work, I would see it crossed out. All right. What about negative 4? If I put negative 4 in here, is it okay? Yep. That's a good solution. That's what you would type in. Okay. So, and you might want to just make a note to yourself that that's extraneous. Okay. You don't have to write that in your work for your, whatchamacallit, for your work on the quiz, but you have to, in the notes, it's sometimes nice. Okay. Let's see where we're at. Let's do another one together. I think I've got a bunch on there, so we've got plenty to be able to do on your own. We're going to skip the fact that it says your turn, and we're going to do it together. Okay? All right. So looking at this one, we're supposed to still solve the rational equation algebraically. Is there anything I would circle for my LCD? No. So we're just going to keep both. They're both red, right? And we would write both of them for my LCD. And this whole writing it off to the side is more for my thinking process than anything else. Okay? It's not a have to do. It's I'm trying to make sure we can see and have somewhere to kind of write our work and our thinking for our LCD. All right. I want to multiply everything by that LCD. So I'm going to multiply by x plus 3. Totally didn't change colors, did it? I'm supposed to change to black. The thing's not catching up. There we go. Erase black. Okay. X plus 3 times x plus 6. X plus 3 times x plus 6. And I really should probably put parentheses around this guy here. Okay. Looking at that first term, what do I get to cross out? X plus 3. And we like crossing out stuff, right? That was the exciting part before Christmas. We got to cross some stuff out. All right, what am I going to do with the 8? Distribute. Good. So what's at 8 times x? 8x. Good. 8 times 6. Everybody good with 48? Okay. Remember, there will always at least be the little 4 function calculator. I might not give you the graphing one, but at least give you something to help you with your numbers if you need it on the quiz. Okay. You're welcome to use a calculator in here. Okay. I'd like it if you could multiply, but if you need some extra help, I need it sometimes too. Okay. All right. What happens? What gets to cancel on this one here? Good. All right. We got to think to some of the skills we used yesterday. All right. I have x plus 1 times x plus 3. What do I need to do there? That's a FOIL, isn't it? Okay, so we're going to FOIL. So it's not that we haven't seen it yet today. We understand that skill. We've had it from before. Okay. All right, what's x times x? Good. Let's see. X times 3. 3x. 1 times x. If you wanted to, could I do that in my head and just get the middle? You totally can. Okay, I happen to be writing it out this time, but you totally can. Okay. All right, what's 1 times 3? 3. Good. All right, I am going to spend a line combining like terms and then a second line moving stuff over because I didn't do this in my head. Had I done it in my head, I would just move stuff over. Okay. So 8x plus 48 equals x squared. What's 3x plus x? Good. Plus 3. I'm going to let you catch up. Okay. Do I have something linear or do I have something quadratic? What makes it quadratic? The squared, right? So we're in algebra 2. We should recognize what a quadratic is. Okay. So if I have something squared like that, what does it have to be equal to solve? 0. So I want to get it equal to 0. The other thing, because we're going to work really smart on this and not hard, I want to make it so I do not have a leading coefficient if I can help it, right? Because I know if I have a leading coefficient, I not only have to do the magic x, I also have to do the box. I don't want to do the box if I can help it. If I were to take this and move it to the other side, wouldn't that put a minus sign in front of it? And all of a sudden, I've created a leading coefficient. But I could take these two things and move them to the right, and I still have this as an equivalent equation, okay? And I don't have the leading coefficient. So I'm going to move everything to the right this time and make a 0 on the left. And it doesn't matter where that 0 goes, okay? It just has to be equal to 0 somewhere. So the x squared gets dropped down. How do I move the 8x to the other side? Subtract. So what's 4x minus 8x? Good. All right, how do I move the 48 to the other side? Subtract. So it's 3 minus 48. Negative 45. Okay, perfect. Okay. What are you really wanting to do right now? It's got to be a magic x, right? So I need two numbers that multiply to negative 45 and add to negative 4. Negative 5. Oh, sorry, negative 9 and 5. Pretty good. Okay. I can't just leave that in the magic x. I have to put it in a binomial times a binomial. This is the proper way to do it. Okay. What property do we need to apply? Zero product property, right? That's some of the vocabulary Mrs. Ballard expects you to have. So that just means split them both up and set them equal to 0. Totally forgot to celebrate when the fractions were gone, didn't I? Oh, well, next time. All right, what are we going to do with that 9 to get it to the other side? Add. Good. What are we going to do with the 5 to get it to the other side? Good. One last thing I need to check is I need to check those out in my denominators and make sure they're okay. All right. So I'm looking at the 9. I'm going to squeeze this out a little bit. So if I put the 9 into this first denominator, does it make 0? No. If I put it into the second denominator, does it make 0? Oh, so that's a good answer, right? Not going to cross it out. I'm going to try the negative 5 now. If I put the negative 5 in the first denominator, does it make 0? No. What about the second denominator? Does it make 0? No. Okay. It's not that these are hard, right? It's just they're long and tedious. There's a lot of things we have to remember to do. Okay. We know how to do all the little steps. It's a lot of little problems embedded in one big one. Okay. All right. Let's see what's next. Okay. Oh, good. We get to do some factoring because we hadn't done enough yet. Let's look at this one that says example A. Okay. I put a lot of examples in there because I wanted to make sure we had enough of a little bit of everything to make sure we had enough practice. Okay. What? So what do I need to do with this guy right here first? Magic X. And they did something weird and made it X's or A's instead of X's. It's okay. We're going to leave it in A's. Don't ever change the variable that's there. Okay. That we run into problems when we do that. I know some Algebra 1 teachers will let you do that. Don't do it. Okay. Get out of the habit. I try to make them X's most of the time for us. Okay. But if I ever don't change the variable. All right. Two numbers that multiply -4 and add to -3. What are they? Oh, gee, those look familiar. A minus 4 times A minus or A plus 1. And I'm totally cheating. I'm being lazy and not wanting to write another line. I'm just writing it underneath. Okay. Don't need to do anything with those two back there, do I? All right. So I'm going to create my LCD. What do I get to circle? What matches? As long as it repeats at least once, that counts as a match. So A minus 4, right? Is there anything else? A plus 1 also. So I don't have anything underlined in red. I get to use both of those things. I only write them one time each. Okay. I have an equal sign. What's the next thing I need to do? What have we done in the last 3 examples? We have to multiply by that LCD, right? Everything gets multiplied by the LCD. Okay. So I've got to multiply by A minus 4 times A plus 1. And I know that's a pain. We're lazy and we don't want to write all that out. We're going to. Okay. Okay, the next step is we want to cancel stuff, right? So here's what I want you to do. I want you to see if you can finish it from there. We started it together. You're going to try to finish it. So cancel what matches, right? And then if you need to distribute or multiply, do that and try to get it solved for A. Check for extraneous solutions. Okay, so I'll give you like 2 minutes. See if you can finish it off. Okay. Have a conversation with somebody at your table, please. Okay, and check your work with somebody else. Okay. Let's take a look together. All right. So, our goal is to get rid of the fractions. We don't like them, right? So, what were we able to cancel in the first term? What happened? What cancels here? They both do. Awesome. So I'm just left with a minus 5. Write it down. Okay. What cancels in the second term? A minus 4. And I distribute 1, which just is a plus 1, right? Okay. What cancels in this last term? What do I have to be careful and distribute? Negative 1. So that's going to go negative a plus 4. Everybody good? Okay. We're going to do some combining like terms, right? We've been doing that for like a week now, right? So a minus 5 equals, what happens with this a and that a? Woohoo. And we forgot to say, woohoo, the fractions are gone, right? We got rid of the fractions. All right, what's 1 plus 4? 5. Is it quadratic or linear? Linear, which means I'm only going to have one answer, right? Quadratic, I would have 2 answers. Remember, your answer is based on what your exponent is, the degree of your exponent. All right, well, how do I move this 5 to the other side? Add it. So what's my answer? 10. I need to double check what that would be if I substituted it in. So all I have to do is check here, right? I put in the 10 there. Do I get 0? If I put the 10 in here, do I get 0? No, so I'm good, right? The 10 is good. It doesn't matter if I check those two because they were the same as these denominators here. Okay, so that looks like a good answer. All right. Okay, we're going to do a little piece of it on your own. We're not going to do the whole thing quite yet. Okay, my goal is to try to get through 2 more. We will probably quiz on this on Thursday. Okay, so that's what I'm aiming for. Okay, I want you in example B to come up with just the LCD. So I'm only going to give you 1 minute to do it. Come up with your LCD. Okay, what did we have to do to this denominator right here? Magic X. Good. 2 numbers that multiplied to 12 and added to 8. What'd you get? So we got x plus 6 times x plus 2. Isn't this the same denominator? That was really nice of him, wasn't it? I won't be that nice. All right, so I have to circle what matches. What matches? Ooh, and it matches like 3 times, doesn't it? It's okay for it to match more than 1 time, okay? How many times did I write it down even though it matched 3 times? Still once. I know that was a little bit new. Okay, anything else matched? X plus 2. How many times do I write that down? Once. So x plus 2. All right, our next step is to multiply everything by the LCD. So I'm going to multiply everything by x plus 6 times x plus 2. And I know it's a pain to write all of that down, but we're going to do it. Okay, in the first term, what cancels? Everything. What's left? 1. All right, in the second term, what cancels? X plus 6. I have to distribute 1. What do I get? X plus 2. In the third term across the equal sign, what cancels? Everything. What's left behind? Woohoo! The fractions are gone, right? Linear or quadratic? Linear, right? So I only have one answer. Okay, so we're going to combine some like terms. What's 1 plus 2? 3. How do I move that 3 to the other side? Subtract. So 2 minus 3 is? Check it out. Can I put -1 into the x plus 6? If it's too much crossed out there, could I come over here to rewrite it? Is 1 okay? -1 okay in that? I'm looking. I totally hit the button wrong. There we go. Is -1 okay here? Yeah. Is -1 okay in this? Yeah, so that actually checks it for me, right? If I just put it into my LCD. So that is a good answer. All right. We've got 3-ish minutes. We're going to finish it off, okay? Sorry, not finish it. We're going to do C really fast, okay? Do I need to do any factoring? No. Okay, so I'm going to circle what matches. What matches? X minus 3. Okay. And then I underline everything in red that doesn't. X plus 3. Multiply everything by the LCD. So x minus 3, x plus 3, right? While you're writing, I know we're not going to finish the last 2 examples. We're going to start those tomorrow. Please work on the homework tonight. You know enough to do the homework, okay? We're going to do a couple more that might have some weird things happen, but you know enough to get it started, okay? All right, because tomorrow I'm going to bring the review assignment's going to come out, okay? All right, what am I going to cancel in this first one? X plus 3. Distribute 7, so 7x minus 21. What cancels in the second one? X minus 3. I got a FOIL. I'm going to do it fast. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. So I FOILed. Okay, cross the equal sign. What cancels? And I'm going to distribute the 5. So 5x plus 15. Woohoo! The fractions are gone. All right, we're going to combine like terms. I want my x squared up front. X squared means what kind of a function do we have? Linear or quadratic? Quadratic. How many answers should I have then? 2. Okay, so I've got 7x, 3x, and 2x, 12x. Double check my arithmetic. All right, -21, +6, -15. Is that right? Double check my work. Am I right? Yeah? Okay. 5x plus 15. If I am quadratic, what do I have to be equal to? 0. So I'm going to go, I need to move these 2 to the other side. How do I move the 5x? Subtract. So 12x minus 5x is -7. And then I'm going to subtract the 15 over. What's -15 and -15? -30. Okay, from there, I'm going to stop there. Pick it up tomorrow on that one. Okay? All right. Make sure you try the homework, please. Okay?